Hey there guys, what's up? How's it going? So, I showed you guys my kind of analog comparator multiplier already, this big triangle thing, but I expanded it, and I made this a full 5-function analog hex, whatever you want to call it, comparator calculator. So that pretty much just means every logic circuit in this calculator is comparator based. No repeaters, no pistons, nothing like that. I only use the 5 items built in my inventory here. And I suppose you could use the redstone torches as a repeater by doing that. And then, now it's pretty much just like a repeater, but this circuit, that just basic little circuit right there, can be built with comparators that I just showed you. But anyway, so let's take a look at this thing, because I think this thing's pretty cool, at least in my mind. Some of you will, well, I was about to say some of you may not see the point in this, but I don't really see the point in it either. It's just, I don't know, popped into my head. I thought it was possible, so it's like, oh hey, I should try to build that. Anyway, so yeah, here's the 5 functions. Add, subtract, multiply, divide. Someone actually requested division. They commented requesting division seconds after the idea popped into my head of like how to do it. And then the last one, modulus, remainder. So that just means, like, let's just say 7 divided by 3, we'll have a remainder of 1 left over. So if I do 7 on the top and then 3 on the bottom, and then flip this modulus lever, a 1 will pop up. But right now I have 14 and 6, so let's just go through these. 14 and 6, add them together, and we get, the rows are just 15 by 15 here, so 15 and then 5, so yeah, 20. Can subtract them, should give it a second here. Yep, we get 8. Let's bring it over here and multiply. You guys have seen that one. Oh, what's this going to be? It's going to be 72? No. It's... I don't do well with math on camera. I'm good with math normally, but just on camera, I can't do squat. What is that? 75 plus 8, so yeah, 83. Wait, what? Do I have the right? 6 and 14. Hold on a second. Oh no, that's not 8, that's 9. So that would be 84. That sounds right to me. 6, yeah, 84 is right. Okay. And then the division. Division was actually all these things I added, like just making this a 5-function calculator instead of a multiplier. Took up, like, all the circuitry for the other 4 functions takes up less space than the multiplier. But yeah, 14 divided by 6, pretty obvious, that one's 2. But then it works for, obviously it's never, the biggest number you're going to get is 15 for just 15 over 1. You see, it kind of does some weird stuff there, but yeah, there you go, 7, 16 over that, and then let's just say I have 14 over here. So if I do 14 divided by 5, 5 will go into it twice, and there'll be a remainder of 4 left over. So, yep, there you go. And it does modulus. So, I only did like a 3-minute showcase of the multiplier, so today I'm actually going to go a little more in depth into this thing. Just talk about what I did, in case any of you guys are interested, but yeah, for the most part, I admit this thing is completely useless, but this is more of a whole educational hobby sort of thing than it is, for practical purposes at this point. But so yeah, let's take a look at this thing. So I'll start with how I just select which function I'm gonna do, which is where you see I have the 2 values, the 2 analog values output here. And when I say this isn't truly analog, of course, just because there's only 16 possible values, but whatever. So you have the 2 different value A is on top here, just moving along this line. And you can see that this is the best way to send an analog signal, because I can't just simply like send it out 16 blocks or whatever and then pick it up later, because now the signal is weaker. It doesn't get renewed. So the fastest way to send a signal with comparators is just kind of like with this pattern, where you go block comparator, block redstone, block comparator, block redstone. So I have A on the top, B on the bottom, and then I built this circuit here. You can see there's 5 of these kind of circuits bunched onto the wire here. And what each one of these circuits does is it just allows the signal to pass through or not. And in here is where I use the torches. Yeah, there's one right here. Again, yeah, I may show it at the end, but it is possible to get the functionality of a torch just using comparators. It ends up being a lot more complicated than you'd think for some reason. But the way these things work is I'll go turn on one of the functions here so that we can kind of see what's going on. I'll just turn on, I'll turn on divide. So you can see all of these other things here. There's this comparator here is being powered from the side, and that'll be true on these three over here, but this one right here is no longer powered. That's just because of how I wired it up here. So those switches basically allow a signal of power strength 1. So you see the signal right here, it's only 1 strength in strength, to pass through, and it will turn off the torches. And once the torches are turned off, it will allow the signal A and signal B to pass through into the logic circuit here. So that's just how each of those work, and that's how I control which function I want. And so obviously there's nothing making sure it's just one function at a time. If I turned on all 5 levers, it would try to display all 5 answers at once. That's how all that works. And then yeah, the display is just all these wires going up here to that board. So I guess I'll be talking about the division and modulus circuit here. Again, they ended up being a lot simpler than I expected. Just because I'd never actually made a division circuit with repeaters before. I'd done multiplication. I think I have a video on that somewhere, but yeah, I'll try to get through this. What we have here is this is the signal A, the stronger signal, of course, since you're not going to divide a smaller number by a bigger number. And then signal B over here is the weaker signal. And then what I do is I set these comparators to subtract mode. I should give it, so just I don't even know if all of you know perfectly how the comparator works, but move out here. I'll try to do this really quickly. The comparator in its normal state like this will allow a signal to go through if the signal from the side is weaker or equal to this signal. So by that what I mean is, like that, this signal keeps passing through, but now if I move this torch one closer, this side signal will be stronger and it won't pass this one through, like that. And then it has a second mode, which is subtract mode, which is what I'm using over there for the division. And what the subtract mode does is it's just this signal minus this signal. So if I look at our subtraction circuit over here, this comparator right here is the entire logic of the subtraction. The addition has 3 comparators for all the logic, and multiplication would have 15 plus 14 plus 13 all the way down to 1, whatever that number is, times 3. You guys can figure that out. Okay, I'll try to hurry this up. And then, so in subtract mode, you can see if I power it from here, it's 14, a signal strength of 14 minus 14, which is just 0. And then, but if I do 14 minus 13, of course it will be a signal strength of 1. And that's the basics of how the comparator works. Hopefully most of you already knew that stuff. But what I do is, you can say I have the signal A just kind of moving along here, and I'm going to change the values that are going into this thing to kind of better demonstrate this. 14 and I'll do 3. So what's going on is at every comparator in here, it's subtracting signal B from signal A. So that means as we start out with a signal strength 14 here, and then after this comparator, we subtract 3. So now the signal is down to 11. And then we subtract 3 again. Here it's going to be down to 8. Subtract 3 again, it's down to 5. Now down to 2, and then it will be nothing after this point. And it'll just stay nothing. So then what we do next, the question is, for division is just how many, well in this case, how many 3's go into 14. So we've, what this circuit is pretty much asking is, alright, is signal A bigger than signal B? Oh, it is. Okay, awesome. Then that means the answer is at least 1. Okay, subtract B from A. Is it still bigger than B? It is okay, add another 1. And it keeps doing that until signal A hits 0. So in this case, there, it will add up 4 1s. Total of 4 there. I'll show you how I add it up in a second. But each one of these circuits here pretty much decides if this signal, as it goes down in power, if this signal is equal to or still greater than the dividing signal. So down here, where we have, signal strength of 2, so even though this is still outputting power, because 2 is less than 3, it won't output a 1 here like it is right there. Hopefully that makes sense. And then that's what's going on right here. This is in comparator mode, and we can see we have the signal B moving over here and into the side here. So this will only allow this signal to pass through if this one is less than it. Yeah. And then it moves into this torch here, and just to invert it and bring it up to full strength, I use the torches kind of like AND gates. Again, if needed, I'll just show at the end how you can make a torch out of comparators. It would just make this thing a lot bigger and a lot slower. But what happens here now is this comparator generates a signal strength of 1 because we have a signal strength of 14, so 15 minus 14, 1. Nice little compact way to make a signal strength of 1. And then a comparator here, so you can see if this torch is on, like it is right here, this thing will pretty much never be powered. Oh no, this thing won't output a 1 because now it's 15 minus 15, 0. Oh, I didn't realize I did that. Well, anyway, you guys get the idea. Oh, in fact, I could actually get rid of this thing right here if I wanted to. But, yeah, and then what it does next to add up all the 1s is, just so the adding circuits are somewhat large. Wow, it made it through. Over here. So instead of putting those adding circuits over here, I had a little more compact of a way to add it up, which was start with a signal strength of 15, and now you see we have all the potential 1s being subtracted from the signal strength. So it starts out as 15, and we subtract 4 total, and now the signal strength is down to 11. And now what we do next is invert it again. So 15 minus the signal strength of 11, and we get 4, which is our final answer. And there you go. That's how you divide with comparators. Right, and then lastly is the modulus here. So I do the same sort of thing. Let me go turn it on. Where I subtract signal B from signal A, kind of one step at a time. And then oh, excuse me, I'm getting over a bit of a cold. Sorry, I try not to cough while I'm recording. But yeah, so we have, again, it's subtracting going down in power strength here. And what it does is it kind of says, is the signal strength above 0, but below the dividing signal B here? Because that's what our answer is going to be. So like what I said was we have a 14, 11, 8, 5, and 2. Oh wait, what? 2? Yeah, it's 2 right here. Is this 2? What? Huh. What's this thing right here then? Did I... Hold on, I'm gonna see... Oh. Oh, I don't think something's right here. Huh. Let me take a look at this circuit a second. Alright, so most of the circuits in here were correct, but every 4th circuit, I think, was messed up. So it was actually just luck that the 2 examples I happened to show were correct, used the correct circuits of this, but it's fixed now. So let me go back to what I was showing you, which was like this goes, so we start with 14, and then we go down to 11, 8, 5, and then 2 here. So 2 is the signal we want to output, because it's now less than 3 and still greater than 0. So what we do is take this signal, and we take the big signal minus this one, because, or signal B, the dividing signal, minus this remnant from signal A here, and then again feed that into a torch to negate it. And now what happens here is that if this signal is still bigger, if the remnant of signal A is still larger than the dividing signal, that torch will turn on and will stop anything from being output to right here. And then of course, if this torch is off, what's going to happen is this signal of 2 here is going to get inverted, and now we're going to have a signal strength of 13 here, but then it gets inverted again, and 2 is output back here. So this circuit here is kind of doubling as both a way to negate or turn off the signal being passed into the output, and also a way to transfer the signal to the output. So yeah, hopefully that makes sense, and that's how you do modulus with comparators there. Yeah, there you go. That's how I made a 5-function calculator with just comparators and a few torches. Anyway, just real quickly, I'm going to set up how you can make a torch-like circuit with comparators. Alright, so if I wanted to get rid of all the torches in my designs here, which is possible, I would have to replace every torch here with this circuit. So hopefully this will show why I just decided to go with torches instead of just prove my theoretical point. But the problem with the torch here is it's completely non-analog. As in, if there's no signal going into it, it will be on, and if there's a signal strength of 15 going into it, it'll be off, and also if there's a signal strength of just 1, it'll turn off. Now obviously that's extremely basic redstone here, but it becomes very hard to mimic that actually in compact and fast ways with just comparators or analog signals. But this is the system here, at least one that I thought of. There may be a extremely simple way that I'm overlooking, but your input would be here, and then the output, or i.e. the torch, would be right here, or the output of this comparator. So you can see I can give it a signal strength of 15, this will turn off. No signal strength, it'll be on over there like I already showed. And if I give it a signal strength of 1, which I can do very quickly by doing that, this will also turn off. So the way that works is, because we have to assume that it's possible that a signal strength of 1 will be sent into a torch, that what we do is remember I already showed that you can do simple addition by kind of inverting a signal, or taking a signal strength of 15 and just subtracting from it over and over. So what we do is we take this signal of 1 and pretty much multiply it by 15 in order to get a signal of a full strength. So because we start with signal strength of 15 here, we go, okay, 15 minus 1, it's 14, minus another one, 13, minus 1 again, 12, all the way down to when the signal strength hits 0 and the signal turns off. And because, well, there might be a way to go every block with this instead of every other block like I have here, but with every other block, this takes up obviously 32 blocks then, or well, 31 if you chop off the end there. But yeah, so there you go. Hopefully you guys learned a little more about comparators today, if you actually watched all this. Well, that's been my project for the past day or two, so yeah, hope you guys enjoyed, and I'll see all you guys later with another video. Oh, I'll put this up for download if you guys want to mess with this jazz here, but yep, that's about it. Thanks for watching. See all you guys later with another video. Okay, bye.